Troubleshooting Layer 2 and Layer 3 Etherchannel. Etherchannel is your way of overcoming spanning tree domination of your network. Spanning tree does its job well. Identifies redundant links and blocks them, leaving only a single link active, which is good most of the time because you don't want broadcast death in your network environment. But sometimes you might say, but how do I increase the capacity? I mean, because if you think about it, you got all these clients sitting up here, all these clients going right here, which are all, we'll just say 1 gigabit per second connections. That's a 1 gigabit per second link. We're going to be bottlenecked right there if we have a lot of transfers going between these two. And then you take it bigger. I mean, if you follow Cisco's best practice network design, you design your network something like this. It's collapsed core, right? Couple distribution switches connected to all these access layer switches. You're going to have a whole bunch of traffic going up to these guys and then down to all these different devices. Up here, down here, up here. I mean, essentially they act as the distribution and core of your network. So you want a high capacity link going between them. Now, some of that can be circumvented by using 10 gigabit per second links or 40 gigabit per second links rather than just 1 gigabit per second uplinks, but even that can be maxed out. Etherchannel allows you to come in and bundle the bandwidth of those links together. Now, it's not as amazing, although it's great. It's not as amazing as it sounds, because when I first learned about Etherchannel, it's like, sweet, so I've got 4 gigabit links. That's a 4 gigabit per second uplink that I have between the two, which is kind of true, but not really. Meaning, this is not like multi-link PPP, where you actually fragment the packets and send exactly the equal data between these. No. What it does is use a load balancing algorithm to figure out what the best way is to optimize the traffic going over those. And most of the time, you'll use source and destination MAC address, to where when this computer accesses this, we'll say server, it's going to hash those MAC addresses together, and based on that hash result, choose one of these links to use. And then when this computer comes over here, it's going to hash that computer's MAC address and this server's MAC address and maybe end up choosing a different link. So the throughput is kind of balanced between the two, but you'll never have any one client getting more than the capacity of one of these links. Right? If these are 1 gigabit per second, you'll never see this guy get more than 1 gigabit per second throughput if he copies a big file from his computer to his server, because it's not actually load balancing between all these. However, on a total, like if you have 10 computers on each side using these, you'll probably see them start somewhat optimized going across these. You're never just want to set your expectations, right? When you look at these, you're never going to see exactly equal traffic going over them. It's just, you might have a telnet session going over one, and you might have a large file transfer going over another, but you're getting the benefit of using multiple links rather than having them blocked. Now let's get into the nitty-gritty. We've got LACP and PAGP, which are the two negotiation protocols of Etherchannel. LACP being the industry standard, PAGP being Cisco proprietary. Matter of fact, the name Etherchannel is Cisco proprietary. Everyone else calls them lag ports, link aggregation. So PAGP, since Cisco was first to the game to create this technology, is Cisco's way of saying that these ports will negotiate with the other side. Why do we need that? Why can't we just go manual and turn them on? Well, because if you turn them on, there's no negotiation whatsoever, and it just assumes that it's going to be in the Etherchannel bundle. But if you ever have a misconfiguration, that could result in a spanning tree loop. Remember, Etherchannel is about bundling these, keeping them active, but what if we have one side on and the other side isn't configured for anything? Maybe it's off, maybe it's who knows what. You've got some VLAN misconfiguration, you're setting yourself up for a network explosion. So usually the best thing to do is to use one of these negotiation protocols. Neither one is better than the other, but this is one of the confusing and big troubleshooting points of Etherchannel is the modes. You actually don't go under the interface and say, I want to use LACP or I want to use PAGP. Although there is a command that lets you pick it, you actually need to go in and say channel group. So when we configure this, we type in channel group and we type in a number. Let's just say 1. It's identifying the channel group because you can have multiple bundles, right? This would be bundle 2, this would be bundle 1, that kind of thing. So it's channel group 1, and then you type one of 4 different words. You have auto or desirable, and that picks PAGP. If you choose active or passive, that picks LACP. You totally can see this one troubleshooting, right? Like, oh man, this one's set to auto and this one's set to active. What's going on? You're talking 2 different protocol languages. Now, they both accomplish the same thing. Why they didn't just say use PAGP, I don't know. Right? So auto is kind of the passive, right? It's the one sitting there waiting for the other side to negotiate. Desirable is kind of the active. And same thing here. So active tries to form an ether channel. Passive just sits and waits for the other side to form. So you can see another troubleshooting state here. What if you set both sides to passive? Well, then you never have an ether channel forming because both of them are sitting there waiting for the other side to make a move. You can configure Etherchannel as layer 2 or layer 3. Layer 2 just bundles them all together and you'll usually turn that into a trunk port with VLAN tags and all that. Layer 3 is essentially the same thing as going under one of these interfaces and typing in no switch port, right? And assigning an IP address and making it a routed interface going between them. But since there's no one interface that represents the whole bundle, you actually create a virtual interface called a port channel interface. You'll give it a number that matches the configuration of all these guys. So you'll say port channel, we'll just say 1 and configure all these guys to be a member of that. Give it no switch port, give it an IP address, and then do the same thing on the other side and make sure that they're in the same subnet, and now you've got that routed interface. It is really handy, going back to that ideal network design, when you are using Cisco's best practice of going layer 3 everywhere, right? And you want to eliminate VLAN spanning your whole network. We'll just say, okay, this is a layer 3 link right here. We'll localize the VLANs so that they don't leave the wiring closet. And we'll use layer 3 between the distribution, between the core, so that we can have that ninja fast convergence between our switches using routing protocols. And ideally, if you can, do it all the way down here to the access layer. That's the Cisco dream. Alright, it's Etherchannel, right? What could possibly go wrong? A lot of stuff. Actually, I've done a lot of troubleshooting in the real world when it comes to Etherchannel. The good news is that most of the troubleshooting is related to misconfiguration. So let me show you the right way to configure Etherchannel to start off with. I'm going to do a show CDP neighbors. I've cross-connected switch 2 to switch 1 using a bundle of cables. Fast Ethernet 201 through 4, and you can see they align to their friends over there on the other side. Now, you don't have to do that, but good grief, why wouldn't you do that to ease your configuration pain? So I'm going to go into, let's do show run interface, fast Ethernet 2/0/1. I always verify the configuration beforehand because almost all the troubleshooting is related to a bad configuration under one or all of the ports. So I'm going to go into global config mode and we'll just leave this at the basic configuration. I'll do interface, fast Ethernet 2/0/1 through 4, and let's do range. This, by the way, is how you solve almost all your issues, is configuring all the interfaces at the same time, because if you do them individually, there's more chance that you could mistype something unless you have Notepad or something going alongside you, which you should. So I'm going to go in here and I'm going to do, let's do switch port mode. Actually, before I switch it to trunk, switch port trunk encapsulation .1Q. switch port mode trunk. Notice I'm configuring all the interfaces at the same time. I'll do a switch port non-negotiate to turn off all the dynamic trunking protocol. Again, I'm putting a good base configuration in here, and let's just do a switch port trunk allowed VLAN add, and we'll do 150 200. I'm just throwing some configuration out there that we've got. Now do a show run interface fast Ethernet 2/0/1. Looks good. Now, why am I? Oh, switch port trunk allowed VLAN 150 200. It's saying add, and I'm adding him in there. There we go. I'm adding him in there, but all of them are already allowed. I was thinking, why did that command not appear? So now those are the only ones allowed to cross that trunk. We should see that mirrored configuration on all of those because I'm configuring the interface range. Now the magical command channel group, and I'll say 1. And we'll type in mode, and this is where you choose your PAGP or LACP based on the command that you type in there. We'll make this side the aggressive one on LACP, right? So this will be the active one. Now notice it says I've now created a port channel interface called port channel 1. Cycles the interfaces. This is not something to do during production. And that's it. So I'm going to go back here. I'm going to do a show channel show Etherchannel summary. There's our big command right here. And you can see show Etherchannel summary, our main verification commands. All of these are sitting at W, meaning waiting for the port to be aggregated. What's that tell me? It says the other side is not configured as of yet. So let's jump over to the other side. I may have to connect. I telnetted into this guy. I may have to move my console cable over. Yeah, I thought so. Hang on. All right, we are connected. And by the way, bonus office cleaning tip. Ever since I've moved my switch stack under my desk, I have found so many dust bunnies as I've gone to plug in this console cable. I'm telling you, just move. That's disgusting. Just move your equipment somewhere that you wouldn't normally have it, and you will find some weird, creepy stuff there. So switch 1. I'm now sitting here. I'll do a show CDP neighbors. This guy's just waiting for the other side to converge, but nothing's going on as of yet because let's just do a show run interface fast Ethernet 104. All of its ports are still in that base configuration. So I'll go into interface range fast Ethernet 101 through 4. And we'll do switch port trunk encapsulation .1Q. Switch port mode trunk, switch port trunk allowed VLAN. And we will do what was it? 50? Oh, 5200? Something like that. It's not real, so we're not going to take down a network. I know I did a switch port non-negotiate. Now, obviously, one of your troubleshooting and this is completely not related to port channel or Etherchannel, is mismatching your configuration between the two sides. So I'm not even talking about, when I'm talking about this list up here, I'm not talking about misconfiguring one side to match the other. I mean, that's VLANs, that's trunking, troubleshooting, all that. This is just related to specifically Etherchannel. So now I'm going to do that channel group 1, and we'll do mode, and I did the other side is active, so let's make this side passive, right? That is configuring a Etherchannel correctly. So now I'm going to go down here and do a show Etherchannel summary. You can see we're kind of waiting right now in our negotiation state, waiting for LACP to discover the other side and get all these ports up and running. You can see they're now all moving into this hot standby mode, which is a transition mode most of the time for LACP. And after about 30 seconds, the ports negotiate and come up. Now, that hot standby mode, by the way, is an LACP thing for additional ports beyond the 8. Etherchannel has an 8-port maximum that it can bundle together. So if you, let's say, configure 16 ports to be bundled, you'll see 8 of them go active. Let's hit the up arrow and just do a show Etherchannel summary. You can see all of these now are sitting there bundled in the port channel. You'll see 8 of them go active. The other 8 will be in hot standby mode. So this is a good configuration. Now, what can go wrong? Well, this typically happens after we have configured the port channel, and this is why I did the configuration in the order that I did. Because once I've configured the port channel, it adopts all of the settings from the interfaces. So the order, and I'll go back to my slide behind the scene, pen. The order of configuration matters. Why? Because as soon as you type in that port channel command, it adopts whatever commands you have on those interfaces, assigns them to the port channel. Matter of fact, let's go back here and do a show run interface path1, right? There's that. Show run interface port channel 1. And you can see all of the same commands that were under this interface just came up and adopted under the port channel 1, right? So now if I go in later and I go, well, let's do interface range. I mean, obviously one of the big ones that you can have is a mismatch port configuration where I go into, let's say, fast Ethernet 1/0/1 through 2 and do, you know, let's just say I do switch port, trunk, allowed, VLAN, add, and let's do 51, right? As soon as I do that, now, bam, you can see it yanks them out of the bundle. I mean, this is network disaster, right? Because you just lost 2 of the links that are in there. 2 of your interface just removed themselves. Now, the good news, I know some of you are like, Jeremy, if you could just finish a sentence, that would be awesome. I will try. So the good news about this is LACP is like, dude, you are broken. I'm yanking these out of the bundle and notifying the other switch on the other side that they are removed. If you just hard-coded the trunk to be on, it would detect the mismatch on one side, yank it out, but never notify the other side, so you're going to have potential for spanning tree loops, right? So now when I go out here and I do a show Etherchannel summary, you can see that 2 of the ports are sitting there in S, meaning I'm suspended. I'm looking at the big S. I am suspended. No longer in that port channel. Why? Because my configuration does not match. The other 2 are sitting there hunky-dory. So that's the mismatch port configuration that I was talking about on the top. So let's do a remove 51, and it's going to be able to detect it like, hey, this is good. Let's go ahead with that. Now, what if I'm sitting there and I do all 4 interfaces and I do switch port, trunk, allowed, VLAN, add 51, right? So I just added another one, and bam, all of these things go suspended. Why now? Don't they all match? Well, all the physical interfaces match. You know where I'm going with this, right? 101. All these guys match. They all look the same. They all got the same attributes, if you will, or configuration underneath. But the port channel interface is now mismatched. It doesn't have that 51. It's not going to continue to adopt the commands that you type in under here. So once you type in a command that's not compatible, your entire Ether channel goes suspended, and you just, I mean, at this point, we caused an outage, right? The link between the 2 switches, I'm looking down at my switch below my foot by the dust bunny, and it is dark. All the lights on the interfaces have gone off, right? So that has completely taken us down, and it's not going to recover until I go into the interface port channel 1 and do a switch port trunk allowed VLAN add 51. Good. Now it's going to realize these guys are all compatible, and boom, comes back online. Well, that hits the first 3 of these things that could go wrong, the last one is the inefficient distribution algorithm. The way that Etherchannel rolls when it does load balancing is essentially it has 8 values, 1 through 8. And based on the number of links that you have, and this is why it's always good to use a power of 2 number, meaning load balance over 2 or 4 or 8 links. If you do something in between like 5 or 6, you're going to get inefficient load balancing, meaning some links are going to be weighted heavier than another, because what it does is it actually assigns these 8 values to specific links. So if you've got 4, it's going to say maybe this guy's 1 and 2, and this guy's 3 and 4, and this guy's 5 and 6, and this guy's 7 and 8. And the way it works is when devices come in and want to go across this bundle, it looks at some attribute of them. Now, most switches, and it's different based on what model you have, most switches out of the box uses the source MAC address value, and it takes it and puts it into a hashing blender. Now, you can't actually hear or see the blender, but it exists inside of there. And you throw the MAC address into the blender, hit the button, it goes 1. Right? 1. Because every single source MAC address is always going to generate the same value. So I throw that source MAC address in every single time. If it's the same one, it's going to be 1, 1, 1. And that always tells which link that guy's going to end up using, because they're assigned the specific values. You throw a different source MAC address, so let's just say source MAC address 2, it could be a 1. It's a hash, right? It just kind of takes that, puts it in some mathematical formula, and goes, oh, that one's a 3, right? So that ends up going across this link number 2. That's why you're never going to get absolutely equal load balancing between all of these, is it is somewhat random. But here's the problem. What if I've got a couple devices, maybe this switch right here represents a DMZ. Now I know you're like, who would use a 48 port switch from Cisco to run a DMZ connection between let's just say a outside firewall and inside firewall over here? I can tell you it is this is where salespeople get involved. I have walked into shops where I have $5,000 worth of switching equipment where I see one connection like this, one connection like this, and one connection like this. And I'm looking, I'm like, seriously, you bought enterprise grade Cisco switches, 48 ports just for your DMZ? They're like, I don't know, that's just what they sold us. I'm like, man, I need to get into sales. Anyway, so this is what was it? Oh yeah, this source MAC address is always going to be the same, right? So what you might want to do is come in here. First off, you can verify what that load balancing algorithm is. You can see the second command I have in that list, show Etherchannel load balance, and bam, I'm looking right here. It's saying for all these different traffic types, and in this switch, the 3750 can actually do it on a per protocol basis. If you're doing layer 3 Etherchannel, layer 2 Etherchannel, you can see based on the source MAC address, I mean, they're all based on that same thing. I'm like, oh no, I don't want that. So I can come in, and the algorithms are going to be different based on the switch. Different ASICs support different things. Again, all this hashing is ASIC based, so it doesn't slow things down. So that's why you're going to see different models support different things, as they have different chipsets assigned to them. So I'm going to do a port channel load balance question mark. And there are all of our options. They're saying, hey, do you just want to roll based on the source MAC address, or do you want to combine together maybe the source and destination MAC address, or maybe you want to do the source and destination IP address, you know, as you know, throw some variables in there. There are even some switches, usually the bigger ones, that support port numbers that you can add on there. To again try and come up with unique values for that hashing. So if you ever see just one of your links getting all the traffic in your bundle, that's probably what's going on. The only other thing that could go wrong is when you flip over to layer 3 Etherchannel. Remind me of it when we hit that load balancing right there. The configuration is exactly the same as what we did. All we need to remember is before we ever do that port channel command, right? So we're into interface, range, fast Ethernet, 1/0/1 through 4. before we ever do that port channel command, type in the no switch port. Right? That's what flips all of those to layer 3 interfaces. Now you're going to see the whole thing kind of fold and collapse because the other side's not configured for layer 3 and all that. But the port channel interface will adopt this if you type it in before you form the port channel. It's okay. I mean, if you did it backwards, don't freak out. Or if you're on the T-shoot exam and you're like, I can't change anything, what do I do? You can always go into the port channel interface and type in the no switch port command afterwards, and it'll take that and handle that just fine. But again, the ideal is to have that all typed beforehand so that we can have a working configuration from the start. You now know how to troubleshoot Etherchannel. I hope this has been informative for you, and I'd like to thank you for viewing.